This is the solution to homework number 1. The Delightful Lighting Company, a manufacturer of decorative lighting fixtures, is planning to tear down its old, outdated factory and construct a new one. As part of the process, managers need to decide whether to build a large factory or a small one. If the demand for a decorative lighting remains favorable, the large factory will most likely generate a net present worth of $14 million. The small facility, about $9 million. The small facility can be expanded at a later date if demand remained high, resulting in a net present worth of $12 million. But if demand decreases, the larger facility will have a net present worth of $6 million, and the small facility will have a net present worth of $7.5 million. The probability of favorable demand is 0.65. The probability of unfavorable demand is 0.35. For part A, we need to draw a decision tree. Remember, we start our decision tree with a decision, and our decision is a square or a rectangle. I like to write inside here so I know what the decision is about. And it's going to be, are we going to build large or small? That means there are two different things that can take place. Events. We build large or we build small. The outcomes or the consequences with their probabilities are 2 for each. The large facility will have a net present worth of $14 million in a favorable environment, which is 0.65. If it's an unfavorable environment, the probability is 0.35, and the large facility will only be worth $6 million. The small facility in a favorable environment, again, 0.65 probability, will be worth $9 million. Unfavorable, still with 0.35 favorability, will be worth 7.5. There's that one other little piece of information though. And we're going to assume that if it's in a favorable environment, they're going to expand out and increase the facility, make it bigger, and it'll be worth $12 million. Now, that's your tree. We need to figure out, should we build large or small? And we want to do an EMV for each, an expected or estimated monetary value. If we're looking for the large facility, we're going to take the probability of a favorable environment and multiply it by what the consequence or the outcome would be, and add to that if it was an unfavorable environment's probability with its outcome. If I did my math right, that should be 9.1 plus 2.1, which gives us 11.2 million. Our expected monetary value for the small facility, we need to think a minute. If it's a favorable environment, we're going to expand. So let's use that information. If it's a favorable environment, the same probability, 0.65%, with an outcome of 12 million, plus an unfavorable, we're not going to expand if it's unfavorable, but it'll be worth 7.5 million. And again, if I did my math right, that should give us 7.8 million plus 2.625 million, or 10.425 million that the small facility is expected to be worth. Looking at these numbers, 11.2 million and 10.425 million, which would you build? A large or a small facility? I would build the large facility because the expected monetary outcome is better than if you build a small facility. And that's how you do your first homework problem.